So I will hand over the time to the moderator, Anbu, now to introduce the speakers.
Thank you, Jocelyn, and thanks everyone for coming back after your break. We will now start the panel, the second panel on science and community engagement and integrated approaches in urban bird management. I would like to now invite our first speaker, Ms. Erin Steckenholz, MS, Texas Tech University. Hi, Ms. Erin. Erin grew up in Nebraska, where she got her Bachelor's of Science from Doane University. She received her Master's from Texas Tech University after working on reproductive biology on Seba's short-tailed fruit bats. During her doctorate, she became one of the leaders of the Pigeon Project for Texas Tech University. This project focused on measuring population size, resource selection, and monitoring movements of the pigeons. So besides the Pigeon Project, she also studies avian meta-community structure and niche characteristics related to species distribution. So a big thanks to you, Ms. Erin, for making time, because we know you're in another time zone and it's very late for you. So thanks so much for coming live for this sharing and sharing on study on feral pigeon management at Texas Tech University. Off to you, Ms. Erin.
Yes, thank you very much. I'm very excited that you guys invited me. Yeah, let me go ahead and pull this up. And you can see that okay?
Yes, we can. Thank you.
Okay, yes. Okay, so yeah, I'll be discussing some of the work we've been doing at Texas Tech University. I'll discuss some of the research we've done and some of the solutions that we've tried to look at for our pigeon problem. So this is mostly going to be from the chapter that I wrote for InTech called Ecology of Feral Pigeons, Population Monitoring, Resource Selection, and Management Practices. Okay, so I'm going to give you a brief history on feral pigeons. You guys probably heard a lot of this already, but just in case, they're descendants of cliff-dwelling rock pigeons that came around from Africa, the Middle East area. They're domesticated by humans for food. And then as agricultural developments happened, they stopped using pigeons. And now we got these feral flocks around the cities that are causing chaos. So they're highly associated with humans because of all the breeding we've done. They cause billions in damages. They consume a lot of grain. They damage building with their acidic feces. They spread disease to humans and other species of birds. And because of their ever-growing population, a lot of governments and a lot of organizations want to help try to manage their population size. So how are we solving this problem at Texas Tech? So in conservation, it's a very similar idea. We look at the abundance of a species. It's typically low, and we want to increase the births, try to decrease the deaths, and look at how emigration and immigration are influencing the abundance within an area. So with conservation, you have problems. What's your problem? What's the solution for that problem, the outcome, and how we can modify the solutions to have a better outcome. So for example, your focal species might have a very low population and you want to bring it up. So a solution might be to quit deforestation. The outcome, we might see some increase in the abundance over time. However, we're not seeing the increase that we want. And so we might look at habitat quality or find a way to modify the solution. This is, for the pigeon problem, it's the opposite. So we want to decrease the abundance by decreasing births, increasing deaths, decreasing immigration into an area, and increasing emigration out of the area. So the pigeon problem here on Texas Tech, first, what's our problem? We have a large population, but how many? How can we estimate the success of our solution? So in this study, a pigeon's eye view of a university campus, my team and I estimate the abundance on our campus so we can get a better idea of when we implement these solutions, how well do these solutions help with our problem? So on Texas Tech campus, we estimated abundance by taking having our volunteers go throughout the campus. Here's a picture of our campus. Go to all these different locations, count, and then we did an N mixture model that is a generalized linear model that takes into account the detection and abundance. What we found was we have about 11,788 pigeons on campus, plus or minus 1,969. So that's about 1,584 pigeons kilometer square. So it's a lot of pigeons. So we know how many pigeons we have, our problem. What is our solution for this problem? So there are many solutions that people have developed over time. And instead of reinventing the wheel, we looked into these solutions and how they've helped other people. But they all have disadvantages. I've heard some people talk about culling or euthanasia. So we could capture the animal, could capture the pigeons, euthanize them, put out poison. However, that's never been proven to be effective. They have high reproductive success. They reproduce throughout the year, and they reproduce throughout the year because we bred them to reproduce throughout the year when we domesticated them. We could capture them and relocate them, but they have amazing homing ability. They have great morphological structures in their eyes. They have imprint on where they come from, and so they are amazing at getting back to the locations. Scare tactics. Some people have put out fake owls. This has been helps at the beginning, but after a little bit of time, pigeons start getting used to the owl not moving, and so they realize that it is fake. Another way we can do it is habitat modification. Make the area less successful for them to reproduce, make them less successful for them to be able to get their food or roosting sites. Food sources. I've heard some people talk about educating people, and that has helped quite a bit. Some places are not able to do that very well. Pigeons like to travel to outside the city for grain, or they do like to eat trash. They're very opportunistic species. And so it's not easy to manage that all the time. For some areas, it's perfect. Some areas, it's not. Nesting sites, you can destroy the eggs. However, this could trigger a response where they produce more eggs over time. And then there's roosting sites. You could put up bird wire, you could put up bird spikes. However, this can be costly and complicated. Another one, which I've heard some people talk about, is sterilization, birth control. Nicarbazin is the main active ingredient in a lot of birth controls for birds. However, this is costly and potentially ineffective. Just depends, again, on your site where your pigeons are moving. It can be costly because it is very expensive. You have to keep giving them this birth control over time. And it could be ineffective because these are wild populations. They're moving around. They could be getting food from other locations. Other birds might be affected by it, but you can put it on top of buildings, so only pigeons will eat it. And birds that eat pigeons will not be affected by them. So the solutions that Texas Tech has decided to look at is mostly nesting sites, roosting sites, and nicarbazin. So by attacking the nesting locations and the roosting locations, we can get a better idea of how to change the environment to make them less successful. A study that has not been published yet, we looked at nesting site selection and fledgling success of pigeons on campus. We looked at characteristics of the nest sites versus random sites, and we found out temperature and percent cover are key factors. Pigeons like sites that are less variable in temperature and have an average temperature that's pretty high up, so they keep their nest nice and warm where they're gone, and that they're constantly covered, that there's about 100% cover. And so finding out these sites, we can go into these locations and we can remove them. We can screen them off. Roosting sites, this is preliminary research right now, so haven't quite looked at it scientifically. We found that pigeons like to roost on ledges versus roofs. The ledges are typically about 5 to 9 inches in width, and They're about 30 to 60 feet in height. And they're typically on the northern side that they like to roost. So by finding these ledges, finding areas that pigeons like to roost, we can put up bird wire and bird spikes to kind of decrease areas of roost site selection. And now for avian birth control. One thing that we found is that it's best to feed them in the morning, right before they fly off to their morning feeding grounds. However, this is something that you have to do consistently. During coronavirus, we did have an issue where it was hard to do it consistently, and we did see a little bit of a bounce back after COVID in some areas. Okay, so we have our solution. We have a few ideas for how to decrease the pigeon population. And we estimated abundance like we did in 2017 with an N mixture model. We did it for 2018, 2018, and 2021. And we did see a decrease in pigeon abundance, which is great. However, is this outcome due to coronavirus? Is it because people weren't on campus, so we had less trash, and so we had less of a food source for them? It could be due to droughts that we've had, and so on. So it's always good to try to figure out how we can modify some of our solutions to kind of keep the decrease going. So re-examining hotspots. So with our N mixture model, we were able to find out some areas that had high abundance versus areas that did not have high abundance. So in 2019, in the red, we see areas that have fairly high abundance. And we've seen that abundance decrease in areas. So for example, 22, abundance did decrease, which is great. And so we can look at other areas that we can attack that are starting to increase in abundance. Another is adding new solutions. What are new ways we can decrease the pigeon abundance? So I've talked about scare tactics and how scare tactics are typically related to having fake owls out there. We're doing something a little different. We're trying to get peregrine falcons on campus and great horned owls. We're working with a local rehab center to introduce young great horned owls onto campus. We don't expect the owls to go out and eat a lot of pigeons, but we're thinking that they'll create this landscape of fear where pigeons will not find Texas Tech as successful. They'll find it as a place that will have a lot of predators that they normally don't have, and will create immigration off campus and have less pigeons immigrating onto campus. Places that have introduced owls in the past, or conservation programs that put peregrine falcons in cities, have found a decrease in pigeon abundance. So when examining how to take care of our pigeon problem, we need to focus on what's influencing the abundance and how we can decrease the births, how we can increase the deaths, decrease immigration onto campus, and decrease immigration onto campus and increase immigration off campus. We have to look at our problem, figure out all those solutions that could work for our area, especially Texas Tech. Not all areas are the same. How is our outcome influenced by our solutions, and how we can modify those solutions to have a better outcome. You need to take into account that the problem will not be solved overnight. This will take years to do. Right now, we're on our 4th, 5th year of doing this, and we have seen a decrease, but it's still not to the manageable levels that we want it to be. It also helps to be very creative with your solution. I like to say death of 1,000 paper cuts, which just means more solutions can lead us to a quicker and better outcome. And so making a multifaceted approach in decreasing the abundance. And you'll never get to zero abundance. We live in a world of pigeons. It's going to continue being that way, but at least we can get to a point that it can become very manageable. And so with that being said, I'd like to thank everyone for inviting me. This was a lot of fun to put together. I'm happy to answer any questions. If you're not able to answer during the Q&A, you can always email me at erinstucknelts@ttu.edu, or I just got a job at Carleton up in Canada. And this is my new email address is the second one. So yeah, thank you very much.
Thank you so much, Ms. Erin. That was really a very interesting sharing presentation, and very thrilled to hear about the outcomes. Thanks for sharing the most recent updates of the project itself, and very impressive on the drop in the population over the 3 years. And even though we don't know whether it's because of the COVID situation or the efforts, but it's very interesting to hear. And I think there are quite a few pointers that we can actually learn and bring forward to in terms of habitat modification. Thanks a lot, Ms. Erin. We will take questions during the Q&A session. However, there is a Q&A panel on the bottom right corner. So if you have any questions, please put your questions there so the panelists can also see the questions that's coming in. So I would like to invite our next speaker in the panel, Dr. Tang Chien from National University of Singapore. Hi, Dr. Tang.
Hi, thanks for the invitation of this forum. Please allow me to share my screen.
So he will be speaking, Dr. Tang will be speaking on the feral pigeon population in Singapore and ecological-based animal management. Dr. Tang Chien is a senior research fellow in the Department of Biological Sciences in NUS, and he got his PhD in 2016 from NUS and worked on multiple projects as research fellow afterwards. Dr. Tang is interested in using the knowledge in the field of ecology and evolutionary biology, particularly the correlation between population dynamics and the environment on the management and conservation of wildlife. In his 2018 project, he conducted field surveys on multiple urban bird species and estimated the abundance of pigeons and the correlation with the environmental variables itself. So based on the results, Dr. Tang is now exploring methods in cost-effective management design on the overabundant animal populations by limiting the environmental resources. So I'm very grateful to have you here, Dr. Tang, and we look forward to your session.
Yeah, thank you very much. Please allow me to share my screen. Yeah, hi everyone. I'm Tang Chien from the National University of Singapore. Today, I would like to share you our research on the feral pigeon populations in Singapore and the ecological-based the management about it. Before I start to introduce our work on the pigeons, I would like to briefly talk about the animals in the city. Cities are anthropogenic environments, which are also considered as novel biomes on the earth. Given that the unique niches and ecosystem services provided in urban environment, only a small group of animals can adapt to and thrive in the urban environment. Unlike the biodiversity in the wild, biodiversity in the city normally consists in a similar group of animals. Normally, we call it urban exploiters, which are highly dependent to the anthropogenic resources. It is inevitable that urban exploiters thrive around us because the resource and the niches can't be easily utilized and occupied by nature species. So looking at this panel to the left, this is what a typical urban exploiter, or maybe let's say pigeon, looks like. They have high overlap with human in space, spatial overlap with human, and high dependency on the anthropogenic resources, but relatively low ability to compete with other species in the nature environment. So they mainly occupy the city environment, urban environment. However, increased increasing cases of human-wildlife conflict occur in the most cities under rapid pace of urbanization globally. Overabundant animal population may cause many issues of human, as you may already know, like if a building is roosted with many pigeons, you will see a lot of feces on the ground, even drop on the laundries and stuff. So that's what every people already know. And however, I would like to mention more about the complications on the animal population itself. Overabundant population may also have an effect, affect the surviving quality of the animal itself. For example, like high abundance among pigeons may facilitate the transmission of diseases, and also you will expect higher parasite load in each individual pigeons, and also the activities of high abundance pigeon under overlapping with human activities may cause a lot of physical injuries and things. That's why normally you can see a lot of pigeons that they have like damaged legs, feet. So, therefore, maintaining a balanced population is essential for the well-being for both human and non-human residents in the city. So we are trying to bring out this ecological-based management. The ecological-based management meet the demand of recent awareness of keeping sustainability of urban development. And the ecological-based management aims to manage the resource or engineer the environment instead of to manage the animal itself. In contrast to the traditional management methods, for example, culling and some indirect removal. For example, like recently, there are also a lot of good examples of indirect removal as the traditional management method. For example, these pigeon lofts in many European cities, they built lofts or houses for the pigeons to let the pigeons stay inside, and then they try to replace the eggs with the fake egg, or giving some chemicals that is more specifically targeted to the pigeons. Because sometimes if you release the chemicals to sterilize the pigeon, some other bird species may accidentally consume it. So this runs quite successful in many European cities, as they also use the product, the eggs of pigeons for research purposes and sell it. So it's kind of, in some cities, it's a kind of sustainable system, self-sustaining system. In addition to all these traditional methods, we would like to stress more on the ecological-based management while managed resource and engineering the environment. There are the advantage of ecological-based management is like it's a kind of long-term solution, and in theory, it's the most effective ones based on like ecological researches, because we all based on the same assumption that every species needs its own niche or its own resource to live. So reducing the resource can reduce the population. And it's relatively humane is because there's no minimize the direct contact with the animal. However, there are also disadvantages. For example, like you need very established knowledge on the biology and ecology of the species to be managed. And also for stakeholders, it's hard to estimate the cost effectiveness. For example, if I use traditional methods like culling, I know how many pigeons I I cut, and then how I would expect a cost with the effect like a number of reduced pigeon. But with ecological-based ones, it was hard to calculate the budget and effect. Therefore, some of the stakeholders may try not to use ecological-based management methods because it's hard to keep it in the budget. Therefore, now is our case studies of pigeon populations. So we performed the population survey of pigeons in 2016 in Singapore or all across Singapore using distance sampling. And then we applied the hierarchical modeling on to involve many environmental variables to model the correlation between the population abundance and the environment. And then we compute the based model. So hierarchical modeling helps us to estimate the density of population as well as identifying the determinant covariance, which are the environmental variables that most has the highest correlation to the abundance. Our results shows that in Singapore there are around 210,000 pigeons, and this heat map shows the distribution of pigeon abundance or density across Singapore. So you can see that it's all the high density area is concentrated at the most urban, the area with higher urbanized level. And also hierarchical modeling tells us we tested 18 environmental variables, and 7 of them, we identified 7 as the 7 environmental variables that mostly correlated to the abundance of pigeons. So the old buildings, which has the engine room at the roof, and also overpasses, the crevice and under the overpasses are likely to be utilized by pigeons as their roosting sites. And also we have vegetation types and the land use types, but these two are categorical. So in management wise, we can't do much to change these. And also we identified the bus stops, feeding incidences, and eating establishment to be correlated with high pigeon density. And these 3 environmental variables are likely to associate with the food sources of pigeons. So based on the studies, we are trying to get some ideas to design decision supporting tools. So to promote the use of ecological-based management methods. So stakeholders can compare the cost and effectiveness of the ecological-based solutions with the traditional ones. So the workflow of this is we collect the population survey data and make correlations between the density and the resources using the survey data and the geographic information systems or different environmental variables. And then through the modeling, we know that which resources or which variables are likely to associate with the abundance of pigeons or other kind of animals. And then we can target the resources within those environmental variables. So for example, like we can design some management methods. For example, if pigeons are likely high pigeon density are associated with like old buildings and overpasses in the city, then we can either block all these crevices or gaps on these buildings or the overpasses to reduce the potential roost sites for pigeons. For the food sources that we identified under these three bus stops, feeding incidents, and eating establishment, we can also design some management methods to reduce the food waste, to educate the feeders, to reduce the feeding incidents and the food waste generated from bus stops and eating establishments. And then we will have like a management target, and then we can compute the quantity of resources to be reduced. And for each individual method that we designed, we can also have the costs of performing such management. For example, like to reduce the potential roosting sites on the overpasses, we need to spend money to putting on the nets, or and then that cost how much, and then to cost how much to reduce how many meters or how much potential roost sites for the pigeons. And then we developed a small like apps to perform these analysis with genetic algorithms. So we can compute, we can mix all these different kind of management method, and then with the given management target, we can calculate the best the cost of combinations of management methods and the cost effectiveness. Yeah, and then these will help us to make the management decisions. So stakeholders can use this result to contrast to the cost and the effectiveness of different methods. For example, the traditional, for example, culling or using chemicals to sterilize. Yeah, that's all for my presentation. I would like to thank the MPOX to funding this project, and my supervisor and colleagues, and Dr. Malcolm, LTA, to provide the data to support our studies. Yeah, thank you.
Thank you so much, Dr. Tang Chien. I think it was a very eye-opening presentation, and thanks for sharing on, candidly sharing on the pros and cons of ecological-based and conventional methods, comparing the gains. I also really like how you highlighted, a different perspective on managing pigeon population and how it's related to the welfare and good health of the population as well. Often people may just look at managing population means it's because of complaints. So I think it is a very nice perspective to also look at for the better health of the populations. Thanks a lot, Dr. Tang Chien.
Yeah,
if
thank you.
For the audience, if you have any questions, please do feel free to put in the Q&A box. Thanks a lot, Ms. Erin, for answering some of the questions that are coming up, so the panelists can see the questions that are incoming. Now I would like to invite our next speaker, Dr. Malcolm So from National Parks Board. Hi, Dr. So. Dr. Malcolm So is currently a senior researcher in the Wildlife Management Department at NParks. His current research focuses on studying the population and behavioral ecology of invasive urban bird species such as the feral pigeons and house crows to formulate measures for their management. Malcolm also studies native birds in projects that include the ecology of the critically endangered straw-headed bulbul that many of the audience may be familiar with, and the community dynamics of urban birds. Birds aside, he also led a project to estimate the population of free-roaming cats in Singapore. Dr. Malcolm graduated with a PhD from the School of Biological Sciences, University of Western Australia, where he investigated the effect of environmental change on montane, amphibian, and bird communities in Peninsular Malaysia. Previously, he obtained his MSc and BSc from the Department of Biological Sciences at NUS. Thank you so much, Dr. Malcolm, for making time today, and I welcome you to start your sharing.
Yes, thank you again, Ambu, for the introduction. So I'll jump right into my presentation. So it's on ecological studies of feral pigeons and house crows. So for the feral pigeon project, I'll talk mainly about the results of which and some of the study implications as to how we can better control them. For the house crows, this is actually the project is still ongoing. So I'll share more on the methods and what we hope to find out from this particular study. Okay. Right. So we all know that, and we've heard from several speakers that abundant human food supply is known to increase pest bird populations in cities across the world. So like in New York, Tokyo, and Singapore is no exception, right? So we're a highly urbanized city, and we also have a lot of pigeons here. So COVID-19 actually offered a very unique opportunity for us, to investigate if a decline in human food during this period of time will reduce the abundance as well as change the foraging behavior of these feral pigeons. So if you want to read more about this particular study that we did, you can read the paper from Biological Conservation. Okay, so the first thing we wanted to find out is whether or not the activity budgets for the pigeons would change when you have these social restrictions in place. So activity budgets mainly are what a pigeon does on a daily basis. And to do this, we conducted this survey called scan sampling of flocks. So for this particular type of behavioral study, we want to know what every individual in the flock is doing at particular points of time. All right, so the activities in which we take note are resting. The pigeon could be resting if it's moving. And the pigeon is foraging. We take note on what it's foraging on, whether or not it's foraging on waste, or it's food that is given by feeders, or if it's foraging on natural sources of food. So for pigeons, natural sources of food would be grass seeds mainly. Yeah, so you can see on the picture on the right, so we have a surveyor that's surveying a bunch of pigeons on there, and she would note down, what every individual is doing. So in addition to resting, moving, and foraging, the other activities in which we take note also are preening. So preening is a form of grooming behavior. Occasionally, you do see pigeons mating. Sometimes they show aggression towards each other, and we note that also, and then other kinds of behaviors also are noted. But I just want to focus mainly on just the resting, moving, and foraging bit, okay? Right, so in terms of feeding and moving, we find that pre-circuit breaker, so pre-social restrictions, about 39% of the individuals in a flock were feeding and moving. And in terms of resting, it's about 38% of the flocks are resting. Right now, if you go into circuit breaker, we notice that there's an increased number of individuals in a flock that are feeding and moving. And there's a decline in terms of the number of individuals that are resting. So it means to say that there are more individuals actively searching for food during the circuit breaker. And you get the same thing also, the same pattern as well for phase 2 HA is increase in the number of pigeons searching for food and less of them resting compared to pre-circuit breaker. So what this means is that because the pigeons are investing, right, more effort searching for food, foraging, and then less of them are resting, this implies that generally the pigeons would reproduce less in terms of perhaps the number of eggs that they reproduce are less, or they have less young. So ultimately, that would lead to a population decline, right, over time. So we have some idea as to what a reduction in food nationwide would, how that affects the foraging behavior of pigeons. But now we want to know, how does that affect the local abundance, right? So the aim here is to determine whether or not changes in pigeon abundance may be caused by a reduction of food abundance during this nationwide social restriction. So for this part of this survey, what we did was we went around to 4 different food source types. So you have your feeding hotspots and your hawker centers, your bin centers, as well as your green spaces. And we survey about 50 of them in each one of these food source types. And now here what we do is we do an area search, and the area spans about 1 hectare, 100 meter by 100 meter square grid. So we survey all accessible areas for pigeons in this particular area. Okay, so in terms of the results, we find that there is a change in the total abundance of feral pigeons in the hawker centers, as well as the bin centers, not so much in the feeding hotspots, although you can see a decline. So here across the different food source types, we find that the greatest decline happens at the hawker centers, right? The bin centers is interesting. You have a bit of an increase during circuit breaker. And we think the reason why there might be a significant increase in feral pigeons at the bin centers at this period of time is because they are getting less food in the hawker centers. And also, you know, people are staying in a little bit more. So there's accumulated food waste in the bin centers, and there are less people also during that period of time that are tending to the bin centers, right? So a little bit of an increase during circuit breaker, and then phase 2 is decline. And we think that's the reason why is because the workers have come in a little bit more and helped to clean up that area. So there's less food waste available during that period of time. Okay, so we looked at how the circuit breaker phases would affect the abundance at each of the food source types, but we also wanted to see how changing the food supply in each of these food source types would affect the pigeon abundance also. So here again, we look at the food abundance across the 4 main food source types, again, green spaces, hawker centers, bin centers, and the feeding hotspots. And you'd see for the green spaces, right, it doesn't matter if the food abundance increases or decreases. It has almost no effect on the rock pigeon abundance. And the reason for this is because in green spaces, you don't get a lot of rock pigeons to begin with, right? So it doesn't really matter so much if you increase the food source in a short period of time. Whereas you can start to see, you know, if you move on to the hawker centers, you are starting to see a bit more of a relationship between the food abundance there and the rock pigeon abundance. So if you decrease the food abundance in hawker centers, you would see a corresponding decline, as you can see down there in the red arrow, in the rock pigeon abundance. And now you would see that relationship becoming stronger in bin centers, so a more significant decline in bin centers if we reduce the food source or the food abundance. And you see the greatest decline actually in the feeding hotspots. So yes, if you minimize it, right, you see the biggest drop in terms of the number of rock pigeons in which you would see in these places. So the implication of this result is really this, you know, if you reduce feeding by people, right, you can effectively start to manage your pigeon population. So overall, our study showed that, you know, if you decrease food abundance, that would decrease the local pigeon abundance. We found also that pigeons spend more time foraging, less time resting during the circuit breaker, and that would have consequences on their reproductive success. Larger flocks are associated with feeding more on anthropogenic food. It's something which we found also with our behavioral study. So all in all, food limitation is vital in controlling the pigeon population. Okay, so now we move on a little bit to crows, and I'll just share one study that's ongoing. So with crows, aside to some of the noise in which they create in their communal roosts, you can see on that newspaper article on the right, you see crows, when they are nesting, they can be territorial. So that poor uncle down there is walking by, probably very close to where a crow is nesting, and he's being attacked by a territorial parent. Okay, so nesting crows can be aggressive, because they perceive these us, we're walking close to the nest, as potential threats to their nestlings. So here, what we wanted to do was to investigate what sort of trees house crows prefer to nest in. So to do that, we brought down a very heavy LiDAR machine to scan 30 trees in which we know house crows are nesting in. And we do this so that, with a LiDAR machine, we can get a 3D image of the tree. So you see the picture on the right, that's your LiDAR machine. And it would scan the nesting tree at different angles. And then below is an image of a tree that is 3D rendered, right? And you can turn, pivot it, at different angles to measure various characteristics. So likewise, we also did the same sort of scans for 30 non-nesting trees. And like I mentioned, we'll measure tree characteristics like the girth, the crown depth. What we think also might be a contributing factor as to why crows select certain trees over others is because of the branching angles. So certain branching angles may be optimal for crows to anchor and build a nest, whereas others maybe not, right? You might be able to build a nest, but it's not very stable. So they might be looking at tree characteristics as such. So, the study is still ongoing. And eventually what we'll do is we'll compare the tree characteristics between the nesting and the non-nesting trees to determine, what is it about the preferences, about these trees that house crows go for when they're nesting. So this sort of knowledge can help MPOPs to manage trees in urban areas so that they are generally less desirable for them to nest in. Okay, so with that ends my presentation. I'm happy to answer any questions.
Thanks a lot, Dr. Malcolm So, for your sharing. I think I have to share at this point that the study that was done by NPARKS about pigeons during the circuit breaker and before circuit breaker conditions was very crucial. That study's findings, which showed that reducing food sources is vital to the management, formed the foundation of the appeal letter that SPCA and ACRES actually wrote to town councils as an effort to, request them to intensify public education efforts in terms of, raising awareness on food reduction itself. So thank you so much, Dr. So, for sharing. Now, if I could invite all the panelists for the Q&A session. We did have some questions that were submitted during the registration itself. But for those participants who are listening in, please do put your questions in the Q&A panel, the button that you see in the bottom right, to put in your questions for the panelists today.